The following audio recording has been designed for learning purposes only. Do not share, distribute, or provide any type of copies, or this audio lesson will not be made available to you. Good luck with today's lesson.
Probably the simplest one to do, have a main. That main would get some values for the sides of the triangle. Is everybody with me here? So input A, input B, input C. Okay. Then you could do a couple of things at that point. Right? So one, you could have a function that you could send those values to, A, B, and C. And that function ultimately would return either a true or false, a Boolean, which on the end, in main, on the return trip at main. Right? You gotta pull that to this. Let me pull that. Okay. Why don't you come? I'll come get you. I wrote over in that fine. Not if it checks it the right drive.
Dude, I'm so stuck in that math exam. I'm trying to find the goddamn thing. I'm trying to find the thing. Dude.
You say big chunk, right?
Oh, God.
16. Right here.
I just bought this thing.
Oh, that's okay. I probably did too.
I've been studying all week. I've been cramming all these things. All I know.
Well, the other thing is, with all the stuff, I can like, I've done it before because I know how to, but I can't just remember how to do it. I literally have to look at my old board and go, oh, okay, that's what I do.
Yeah, I mean, I should.
Anyhow, so it should be a pretty simple program. Set the values to the function. The function will then in turn look at this based upon, it would go through and calculate this out given the three values. Okay, so A, B, and C. So the first thing you do in that function is you multiply A times A or A times 2, some version of that, right? Get those values and then come back and look at this guy here, okay? If these two add up on the square, right, I'm assuming these are float values on the square, to this guy squared, you have a right triangle. The problem comes into play is which one of the three is the hypotenuse. So you've literally got to check A and C, A and B, B and C, and so forth. Each one of the three possibilities to figure out which one is the longest side. Does that make sense? Any questions on that?
I wrote the wrong program.
No. It won't be the first time. So the idea is, the classic example here is 3, 4, 5. A and B, square that is 25, right? But you need to figure out which one is which. So the conditional needs to go through each one, okay? If you're going to do it absolutely correctly. My main focus in this is I want to see how you tackled the problem and the code you wrote to facilitate that. Does that make sense to everybody? It's sort of like the project. I want to know what you know, minus any crutches. Okay? So when you went to solve this, did you break the problem down, et cetera, et cetera? Okay? So the return trip here would say, if this is true, right? Squared, once you determine, right? So you could have done a conditional with at least 3 combinations. Okay, A and C, B and C, and so forth, okay, to figure out which one is the largest side. And then execute that. If this is true, return a true value on that function to determine whether this actually is the right triangle, yes or no. So back in main, the statement after, right, because you're going to call this function with like an if right kind of function with A, B, and C, and you're going to set that equal to result or something, response. Down here you say if response equals true, because I saw a few assignment statements in the conditionals, which I thought was interesting. If that's true, print. I don't care. We got one, or it's true, or whatever you'd like to have, that phrase in main. Does that make sense? That's really all I was looking for in the end. So something on that order. Okay? Now, if you're completely off in left field, that's a whole different problem. Okay? But I needed to know that you understood what this is, because this was going to require you to do these assignment statements, pass arguments, parameters, etc., etc. Because, my friends, we are going to step off the diving board now. We're going into the deep end of the pond. Okay? As of right now, right today. Does that make sense to everybody? So that's what I was looking for in the code, and I needed to see a program that supports that. Okay? Questions? Does it make sense?
Yes.
Okay. Yes, sir.
I do have one question, but completely off subject. But the project one final submission, will we submit anything on the
Yes. Yes, I wanted to see your final presentation and your final code. But I handed out grades accordingly. Right? Everybody saw the grades. And just a quick reminder, if you did not present, you know what the consequences of that is, right? I got to go back in and I'm going to wipe out all of your part 1, part 2, part 3, part 4, part 5 grades. That was stated long ago. That's part of what's going on here. So, with that, I'm going to go back down and get our colleague, and we're going to continue on. So, go to chapter 8, right? And we're going to start over here, all right, on the real world, software world version. We'll be right back.
We're on week 8. Oh, no, week 7. Chapter 8.
I don't see real world.
Any more questions about that conversation about the midterm? Right? It's 25 points. It's not a big deal, but I need some sort of placeholder to give me a little bit of confidence as to where you are technically. Okay? All right. So now, my friends, we're heading into Chapter 8. Chapter 8 And what is to follow from a technical perspective is going to be the space we're going to be working in. Okay? We're going to be talking in terms of objects and all of that stuff that goes good. How many of you have had this conversation? Object stuff. Nobody? A little bit? All right, so let's talk about it in terms of sort of the real world and the software world. Okay? Maybe we can draw some parallels. Okay? So, we'll forget about this guy for a while. So in the real world, and I like to use this example because any street you drive down USA will have these. Right? So if you drive down a street next to the college here someplace, you will see what on that street? What? No. You'll see a house. Houses. Many of them, right? That makes sense? Yes? You see a house, you know, and there are all kinds of different configurations, right? Different styles, different kinds of brick, some with garages, some without garages, all of that sort of look, right? And they're typically kind of on the unique side, right? Does that make sense? Drive down any street. Yes? Everybody has a visual model of a house. Right? So, as part of that, right, every one of those, right, has a number of attributes. Right? So, things like number of bedrooms, maybe number of baths, style. You know, is it a colonial? Is it a ranch? Is it a tri-level? Is it a quad level, etc.? A split level? What else?
Stairs.
I'm sorry?
Stairs.
Okay, could have stairs.
Some have garages, some don't.
Garages,
Basements.
right? Garages, basements.
Pool in the backyard.
Well, that's not something that would typically be part of the original construction, right? So, what dictates this? You know, so you're in the real world. How do they just grab a bunch of raw materials like lumber and pipe and electrical wire and stuff like that, and just throw this thing up? What do they use? Use something like a road map of some kind to construct this thing?
Blueprints.
A blueprint. Okay, a blueprint. Does everybody follow what I'm talking about here, right? So this is a document that when you look at the document, right, for example, looking down on that document, it'll tell you, for example, how many bedrooms perhaps and how many bathrooms and all of these kind of things, right? That sort of dictates the structure. Is everybody with me here?
Mm-hmm.
That makes sense. Any questions about that? And the guys that do this, the folks that do this kind of work, I'm sorry for using the guys thing, but the folks that do this type of work would be people like carpenters, a couple kinds of carpenters, like there's a finish carpenter and a rough carpenter, right? Plumbers.
Electricians.
Yeah, electricians. So you're
Safety
getting it?
inspectors.
What's that?
Safety inspectors to make sure that everything's built up the right way.
I suppose, right? But electricians, cement guys, right? Cement / bricks. Yeah, the junk phone calls are crazy. Anyway, so these would be sort of the folks that do the work. Do you agree?
Mm-hmm.
They look at that blueprint and they say, oh, I need to do this. I need wiring from here and sockets. I need to run some plumbing. I need to stack the bricks in a certain way, et cetera, et cetera. Are we all sort of in tune as to what's happening? So these would be, for example, some of the attributes. Perhaps not all of them, but some of them, right? And these would be the folks that sort of do the labor, do the work. Yes?
Correct.
They also probably have a general contractor. What is this person or group of people's responsibility?
Isn't their job to find everybody?
Managing all of this stuff, right? They're managing the overall picture, right? They're like the building, okay? Are we all still with this in the real world kind of thing?
Yeah.
So, attributes. The worker types, right? So this is the real world. And you can look down any street, USA, for that matter, any street globally, right? You might have little different kinds of structures, but they would have this kind of a house thing, right? Some sort of, even if it was a group of apartments, right? But they would have attributes like this. They'd be built according to some kind of a blueprint, and they would have this workers that would do these kinds of tasks, right? We're all in agreement here? So now, let's go from the real world, let's go over to the software world. Okay? How do we build a house, for example, in the software world? Any ideas?
You dig a freaking pit.
In software?
Yeah.
You may
lay
end
a
up,
foundation.
We will lay the foundation. Okay. So over here, right? We don't use a blueprint. We use something called a class definition. Okay? Class definition. That's our blueprint. It's what dictates what we're going to build. Okay? These attributes here, we can have direct, exactly similar attributes. Okay? In the software world, right, these attributes have a slightly different name. They're called members of the class. Okay? So, over here, if you wanted to represent the number of bedrooms, what kind of a data type item would you want to use? An integer, right? Does that make sense? Although, I suppose you could use a float. Is there such thing as a half bedroom? I don't know. But let's just say integer. How about number of baths?
That one you can use a float.
I would say that probably needs a float because you can get like a half bath or something, right? I don't know if you can get a third bath, but at least a half bath. Right? So, float. How about style? Some sort of a string, right? So it would be like colonial, ranch, tri-level, right? So it'd be some sort of a string. Okay. Stairs. What would you have for stairs?
Would you have like an integer for each step?
To begin with, I would probably just say, does it have stairs, right? Because certain styles of houses would have stairs and others wouldn't.
Maybe like a callable function, something.
I'd probably go more with something like a Boolean, right? Boolean would say, do you have stairs, yes or no? And that could be dictated by this. Right? So if you have colonial, you have a second story, you're going to have stairs. Now, you may have stairs also if you have a basement, right? Boolean, yes or no, do you have a basement? And if so, you're probably going to have stairs or not, right? Does that make sense?
Mm-hmm.
To represent those kind of attributes. All right? Same thing with the garage, right? Again, this would to be determined, right? Do you have a 2-car garage, 2.5-car garage, or you don't have a garage, right? Those are sort of the things you would see if you looked at any house USA. So I would say, to begin with, at least a Boolean that says you do have, yes or no, a garage.
What if
Attached, detached. Well, that could be some sort of an attribute that you could add. Remember, this is not the complete list.
Right, well, I'm saying, like, if it was, let's say it was the attached.
Could you, yes.
Would that fall into,
Yeah,
like,
I mean,
number-
obviously you could put a conditional in here that says, is it an attached or detached garage, yes or no, right? So you could do some sort of secondary thing here if you'd like, right? Keep that idea in mind because we're going to come back to that. Yes, sir.
What is the equivalent of a blueprint again? For
Class.
Class definition.
And so the object. Okay.
We're coming. Okay? So we've got this part of it covered. Do we agree?
Yep.
On the software side. Here's our blueprint. Here's our attributes. Here's where it gets interesting. Guess what? We also have these. We have the workers, the laborers that build the structure for us. Does that make sense? On this side, right, so over here, attributes are members. That's the classic OO term for them. And the term over here for these workers are called methods. Okay? And sort of the unique part about this is that every time you create an instance or you create a house, right, not only do you get the members, the attributes, but you also get a set of methods, a set of functions, specifically to be used by instances of that class. An instance is an object of the house. Right? Does that make sense? We're going to look at it in much more detail, right? But I'm trying to draw some analogies between this side of the world and that side of the world. Okay? So we have workers. We even have a general contractor. He's got a really special name. His name is called constructor. Okay? Does that make sense? We're going to come back and we're going to look at this in the software space. Okay? And then we're going to go back and look at what's in Chapter 8. But I needed everybody to kind of get to this page. This is sort of the initial leap that you need to make. Does that make sense? Questions? Do you have sort of a rough flavor of what's happening here? So here's the real world, and here's the software world version. Questions? I'm sure there's a million of them brewing around, right? But we're going to come back now. We're going to go look at what this might look like. Yes, sir?
You said, so if the object in the real world is a general contractor?
Well, no. The general contractor is the overall person responsible for building this, right? He's the builder.
Okay.
His label is called general contractor. On this side, we have the same guy, and believe it or not, his name is a constructor. Okay? His name is the constructor. And we're talking in terms, remember, the concepts we're discussing here are the classic object-oriented concepts, regardless of language. So, learn it now, learn it later. My friends, you will learn it if you want to be in this business. This is the only language in the real world. I mean, in real world for software development. We talk in terms of objects. So let me take one more step into really deep water now. So you currently have a straw. I'm about to add 3 levels to the straw with this next statement. Every time you create an instance of the object, you create a house in software, you get all of these currently, right? These are the ones we have listed. There's obviously many, many more. And you get all of these. So, in the past world, in our previous life, right, we had the simple data types. We had ints and floats and strings and lists and tuples and so forth. Okay? Now, those are nothing more than simple elements inside of this class. Does that make sense? We've got ints and floats and blah, blah, blah. We can have arrays in here. We can have lists. And tuples all part of that overall structure. So in the past, when I said int I, and I said what is the data type of I, the answer was integer, right? When I said int I, we defined something as integer, right? Now, when I ask you what is the type of this, what is that answer?
Class.
No.
Object.
It's of the type house. It's of the type house. Like I said, here's a few more straws for you. All right? So when we create an instance of the house, okay, it is of the type house. And that type contains all of this and all of this. Not just int I, or list so-and-so, or dictionary, whatever. Okay? You get the entire thing in one shot. Okay? Is everybody kind of following along? So we are now into what's called abstract data types, truly abstract data types. They're self-manufactured. They're, when you talk to somebody who's in the art world, does anybody know what an abstract painter would be?
Somebody who can't think.
Picasso.
Okay, well, he said somebody who can't paint. Let's be a little nicer here. What's an abstract painter?
Someone who paints the world in a different way from being conventional.
Okay, but I think it's a little, that's sort of maybe the media version of abstract.
I've taken a few art classes.
It's probably more on the order of, it's that artist's perception of something. Does that make sense? Mm-hmm. This is the way that artist sees it. Okay, like Picasso was a great abstract painter, but he had his own sort of unique way of portraying it from his perspective.
Especially when it's painting Guernica.
Well, let's not go there.
I like that.
So, do the data types that we're using so far consist of one large class?
No. Nope. Classes are completely now, like I said, we're out of the simple world. I hope you enjoyed it because we're leaving. We're going on. We're sort of saying, okay, we did math, addition, subtraction, multiplication, and division. My friends, now we're going into calculus. You needed that foundation to get you there. Okay, because those simple data types are what's in here. They're the members in the class. Okay?
So, all the data types for house is simply of the type of
House.
Of the type of
House.
Of the type house.
Yeah, when we create an instance of house,
Right. And so, of the type house itself is a class.
is the class definition. Okay? Let's take a look at what this means now. Okay? It always helps to sort of have a little foundation, right? And this is one of my problems with the textbook we use, because it doesn't discuss this. That's why we went the path we just came to get to here. That's great. I need a little jackhammer action here. All right, so let's go take a look at what this looks like now. Okay? It's kind of fun. It's a little exciting. And again, this is all in sort of support of our little field trip. Okay? Did we talk about the field trip yet?
You just mentioned it.
Yeah, we're going to go on a very short field trip. We're not leaving the room, but we're going to go on a short field trip, and we're going to work on a blackjack game, creating a card game. Okay. So let's go out and let's open up some Python here and see what this might look like. Like I said, it's all entertainment.
So,
Go ahead.
okay. So with the object house, inside of the object house, It is kind of like, it's an abstract data type called house, right?
Yeah, it's
And
a data, let's put it this way. It's a data type that we created.
And
It's
it's-
not an int or float or this.
And
That's
there's-
sort of what I asked.
And
earlier.
in the class house is going to be all of its
Attributes.
integers, its floats, its
Yeah,
buildings,
all
and
of the
whatnot.
attributes.
And the layout is going to be kind of like another class that, or I guess the workers are like, it could be a different class that like
Well, let me explain something.
get output out of all
These
the data.
guys, we used to call them functions.
Okay.
We used to call them functions. Now they're called methods.
Okay.
Okay? This is there's nothing really new here short of the fact that we're going to glue all of these pieces together into this big homogeneous thing now. Right? Not only are you going to get the data, but you're going to get the functions to manipulate that data. Does that make sense? And they're specific to an object or an instance of house, right? So I'm throwing around a couple terms here, right? So I'm attributes are members, functions are methods, instance/object are interchangeable. We've created a class, an instance of the definition or the class. This guy here, this blueprint for house, right? So let's go do that. Let's go do that. Come on, let's have some fun. Everybody into the pool. Just going out and opening up Python. Like I said, here's the other part of the message. In order to take advantage of Pygames, to use Pygames, and for that matter, pretty much all other game engines, it's all object-based. It's all classes. Okay? So to be able to use that, you have to understand this. Okay? So we're going there. We are going there. So let's set this up. Here's our shell. I'm going to get a new window. Right. So let's follow the standard protocol. You know how all that stuff works. PF main, right? We're going to go down here and call main. Okay. And now let's get to our class. Let's get to it. So I'm going to create a class called house type. And might have to make some changes, some improvements. Right? So we're going to start out real simply. Right? And anything that's underscore like that, right? These are system specific standard naming conventions. Okay, and we're going to see several of these. This one here, the underscore underscore is the constructor. This is the constructor. So when we say I need to make an instance or an object of house type, we're calling this guy. This is our function. What do we call him now?
Constructor.
No, it's a constructor, but we call it a method. It's a method. Okay? So let's make it real simple first, just so we kind of get our boots on the ground. Okay. Ready? Here we go. House equals house type. Then, let's see what happens. So, my friends, just like at the beginning of the course, let's see if we can create an instance. Let's see if we have some problems. So when I execute this line of code, what this is saying I'm going to create the object or the instance called house, and I'm going to use the class name house type, which in turn will call our constructor. And what should we see if this is good?
Say, hi, I'm alive.
Hi, I'm alive. And we will have created our first instance of house. Our first instance of house type. Right? Our class name is house type. Let's see. Let's see where I am. Desktop. Ready? We have a problem, my friends. We have a problem. And this is the other, there's going to be several sort of tricky points here. Okay? So the first, sort of the next sort of piece we need to get our arms around is the idea that every object or every instance in this particular case of house type that we create is unique. So if I want to know about a specific instance, a specific house, I have to use what's called self. Okay, self means I want to talk to that particular one. Okay? Here's where it gets a little odd. So I need to put an argument in here that says self. It really, okay, here's the thing. It really is not a parameter. It's simply there that says, who am I talking to? I'm talking about this object, this particular one. Okay? So let's see if this helps. Let's see if this is my problem. Looky, looky. So we've created our first instance of house type. Called it house. Does it have any attributes or arguments in it? No attributes, no members yet. Okay? But we're able to do it. So if I wanted to, think about this, if I wanted to create 5 versions, 5 instances of house type, in other words, I'm populating 5 houses, building 5 houses on a street, right? All I need to do is that, and I'm going to make it even easier for us to identify them. 3, 4, 5. So when I execute this code, we should see hi, I'm alive 5 times. So we've created 5 instances of the house type class, 5 house type objects. And they're known as house 1, house 2, house 3, house 4, house 5. Okay? Is everybody with me here? So if you were to think about this in the bigger picture scheme, right, you would have something that looks like this. 1, 2, 3, 4, and 5. Each of which right now has no attributes. And it only has one method. What's that method called? The constructor. Okay? So they each have this. I'm going to make these diamonds, right, sort of following the OO conventions, right? All right, and this is the underscore INIT in each case. Does that make sense to everybody? Mm-hmm. Each one of those has the same thing. So, pat yourself on the back. You've now created 5 objects of house type. Each one is called house 1, house 2, house 3, house 4, house 5. If you wanted to know anything about a particular instance, a particular house, right, you would have to use the instance name. So house 1 or house 2 or house 3 or whatever. We're going to come back and look at that. But I want you to sort of think about this, right? So each one of these guys, house 1, house 2, house 3, house 4, and house 5. Those are the instances or the 5 house type objects we built. Is everybody with me? Okay. Everybody good? All right. Let's start adding to our class definition to our blueprint. What?
Does it have to be given the argument of self?
That is a requirement, okay? And you'll see why that's the case shortly. Self is very important, as I said. In this case, who's self?
The general contract.
No, who's self? House 1. In this case, self is house 2, house 3, house 4, house 5. They're absolutely independent things. Okay, everybody rolling along here a little bit. So let's go out and let's add some attributes. Okay, so I'm going to come in here and I'm going to add one of the attributes. So let's put in a num of bedrooms. Okay, no problem. Right, MBR. Okay, and I'm going to say, and just for conversation, NBR equals input. And actually, it's int of input. Why am I doing this? Huh?
At the same time?
Well, yeah, but how does it come in from the keyboard?
Oh, it's a string and then you're turning it to the...
Because we want it to become ultimately, what's it say right here? Integer, right? So, how many bedrooms are in this house? Right? Then we're going to send that in. But in order to get it to be part of the actual instance, we actually have to set some values up. So I'm going to add NBR, right? Because remember, who are we calling when we create our house 1 instance?
House 1.
No, who are we calling? What am I calling when I do this? No.
The constructor?
The constructor. This guy here. So if I want to get this into that structure, and for that matter, all of the other structures, I got to add it in.
Mm-hmm.
Right? So, let's put in NBR. Okay, NBR. And then I'm going to say, ready? Self dot num of bedrooms equals NBR. Now I've got that there. Okay, I've brought that. I have my member, and it's being set as part of the constructor. Remember, the constructor is the guy that builds the framework, that's responsible for getting everything in the place where it's supposed to be. Right? He's following the class definition. Does that make sense? So far? All right. So while we're in here doing this, I'll leave this hi, I'm alive, but typically you want to know that what the status of your instances are. What are the values of our attributes, our members? What's the status? What is in those items? So, time to introduce another method, standardized one. str underscore underscore, right? And I'll add the self, right? And I'm going to do a couple things. I'm going to say rep equals house instance attribute, or I'm going to call them house instance member values. Okay? And And I'm going to put a \n on this. \n, does anybody know what a \n does for you? Carriage return line fee, right? Takes you to the next line. And then I'm going to say REP equals REP plus self dot num of bedrooms, and I'm going to do an str on that guy. Why is that? What am I doing? Yes. So I'm going to do that. Then I'm going to add the quote \n again to this guy, right? And you ready? I'm going to do a return REP. And down here, I'm going to do something shocking. Ready? Print house 1. So let's see. Do I have everything in there I need? Maybe not, but we'll find out shortly. So now, right, remember what we're doing. We're checking the status of the members for an instance of the class. So another standardized method, and it's actually not a method, it's a style, right, is the __str__. Okay? This is a method that will give you the status of the members at this time, right now. So I'm creating my instance. I'm sending in this value. This guy here calls the constructor. It sends in the value. Remember, self does not count. It's saying I'm talking about this instance. What's our current instance name, object name? What is self here?
The house, right? Each house?
House 1. House 1, right? This is self. So when I get to this line here, so I'm setting the values, and when I do this, it's actually calling this guy here. And that guy is telling me, here are the values for the members for this particular instance. Okay? Again, this is going to take some time, my friends, to get used to. But this is a very powerful paradigm in the overall picture of what's going on. So let's see how bad off I am. And if it's a problem, so I'm going to say 3 bedrooms, hit enter. It shows my 3 bedrooms, right? Correct? No problem. Where is it bombing now? It's bombing on house type 2. And what's the error? It needs what? Needs me to add the NBR value, right? Right now, NBR is equal to 3. So it says, house instance member values are 3. So we should probably do a little bit more work here so we know which member we're talking about, which attribute we're talking about. So I'm going to put the string on here that says of bedrooms. So now I'll have that identifier. Let's run it again. So this value of 3 won't be sitting in the middle of nowhere without any idea of what it is. Right? What is that member or attribute? So we're going to do it again. I'm going to say 3 and number of bedrooms for this particular house instance. Okay. You with me here? So this guy calls the str method. I've got it defined as such. Now we're getting an error on this line. Why is that? Because we're not sending it the NBR. The constructor says, hey, I can't execute because I don't have a value for NBR. We don't have this in there. Does that make sense? So let's do that. Let's add NBR to all of these. And to sort of clear your mind, I'm going to do this for each one of these. So that's for 2, here's for 3, here's for 4, and here's for 5. And I'm going to call, I want to see what the values are for each one of my new instances. So there's 2. So instead of house 1, we're going to print 2. What is the status of house 2? So let's, after this one, let's do it there. And so this is going to be 3. I'm going to clean this up in a second. And then this is 5. Should be house 4. Here's this guy here. This should be house 3. So let's break this up a little bit so we see a little clearer as to what's happening. So there's 1, 2, 3. This guy up 1. Put him in here. Drop this guy down. House 4. We are house 5, so this should be house 5. So we're going to ask for each one of our instances the number of bedrooms. Right? So the first one I said 3. This could be 2. This could be whatever. And we will, my friends, be able to see what the attribute values are for each one of these guys over here now. Right? House, remember, self in each case represents these separate instances. So let's run this code. Okay, how many bedrooms for the first one? 3. How many bedrooms for house 2? 2. House 3? 5. House 4? 4. And house 5? 1. There you have it. The attributes have been set. So, we have 2 methods now over here. We have the constructor, underscore init, underscore, and we have the underscore str, the status method, for each one of these objects. Right? Is everybody following along? And we have a single attribute, which is num of bedrooms, in each one of these. Right? Each one of them. One attribute and 2 methods.
Now, in the principle, can we like identify each house by the streets and brick house?
Well, okay, let's put it this way. Here's what I want you to do. I want you to go back into the code now. And I want you to take, let's do the simple one. Let's do style. I want you to add that attribute. And I want you to add that to the status method. So we'll see number of bedrooms and the style when we execute the code. So make a code bias to make that happen now. Shouldn't be terribly hard to do, right? You have the model in front of you for house 1. Isn't this fun? We've just left the planet. Modify the code to solve the problem. You ready for code? About 3-4 more minutes.
Mr. Slice,
Yes,
could you repeat what you want us to do again real quick?
So I want you to add the style member
Okay.
to our class definition, get the information from the user, and display the status of each one of our classes, each one of our instances. Okay? Should take about 5 changes, maybe 6. Maybe. This is fun stuff, guys. No. Everybody get it done? Good. What's that? Think. All right. About another minute. Ready? Here we go. So we have to do a couple things. So you got to modify that blueprint to take into account, right, what's happening. So that means I got to go into the constructor, and I'm going to put in ST, and I'm going to get this guy. Style. And set the value as ST. And I'm going to modify this guy here so that when I ask to see what the values are of the status, right? So I'm going to take here and I'm going to say style equals self.style. What is self.style? What is style in this particular case?
Style of home.
Right, but what is it in terms of the class? What are these called? No. Methods are the functions.
Remember?
It's a member. It's a member. It's an attribute. Right? So once we got that done, so I'm going to leave this guy alone, but I'm going to use him as a model. And I'm going to say, instead of this, I'm going to say STYL. STY, what is the style of this house? Of this house. Okay. And then I need to take STY, drop it in there. And everything should work, so I need to do this.
So you didn't have to do rep equals rep plus style?
I did it right here. Right?
Right, so for example, like you have rep equals the house instance number of value, and you have rep equals rep plus, and then for the third one you didn't have to do rep equals rep plus.
What third one? What do you mean? It's there. This is house 3. House 3 is there. And house 4. Right. And house 5.
Don't you have to make STY a string instead of an integer?
Ah, you are correct. So I don't need this. Right? Because it's coming in as a string. Right? So I don't need to do the conversion here. Here, or here, here, or here. Or here. And I actually don't even need to do it here. Right? Because style should be a string coming in. Ready? Let's see how we did. How many bedrooms? So I'm going to say 3. Style is ranch. Looks like my stuff is showing up. Second one is 2. Colonial. It's awfully small. Colonial. 2, 5. Tri-level. 5, 4. Split. Level ranch. And 5 should be 1. We're going to call it mailbox. Okay? There you have it, my friends. We've just expanded it so we have our attributes in place, right, for each one of our objects. Again, we've now added an additional attribute right here, and it's called style. Each one of the instances now contains style.
There was a way to write our games using object-oriented programming, wasn't there? I mean, if they had enough like functions going on.
Oh, there's always a better way. There's always a better mousetrap. Right? We weren't ready for this yet to make the deadlines.
Yeah. But I mean, at a certain point, passing around from function to function is like becomes more complicated than this could ever be. You know,
You have yet to see where this goes.
Okay.
All we're doing is creating what is that instance look like.
Right.
We're not talking about collision. We're not shooting anything. We're not moving. We're not doing anything.
Text adventure game, you know?
Oh yeah, you could use this.
This would have made things a little less complicated.
So let's on that topic, okay? On that topic, think about this. You have a class called enemy, right? The enemy has its attributes. It has its methods, right? I want to create a wave of 500 enemies. What would I have to do?
In my loop.
Create 500 objects, put it in the loop, and boom, you're done. Here's your 500 objects. Right? Now remember, we're doing this sort of the hard way. Not the hard way, but the simple way so everybody kind of understands what's happening here. Right? Again, all we're doing is creating instances and displaying the value of the attributes. Does that make sense? We don't have any of the other methods, right? So we're going to start, as this continues on, right, we're going to start adding methods for movement, adding methods for collision, all of that kind of stuff. Those are all going to be methods in support in the class. I mean, we're not there yet. We're probably 2 weeks, maybe 3 weeks away from doing that. Okay? Like I said, we got to go on a field trip here. We got to learn about the garage classes first. Okay? So what I'd like you to do to think about between now and Thursday is how would you now turn around and modify our class definition to have all of these attributes in it? What would you have to change? Does that make sense? Don't forget, we've got some specialized things coming yet. Right now, all we're doing, and this isn't an assignment yet, but I want you to think about how you would do that. If you want to play around with this code, be my guest. Right? Create the object. It has maybe 7 attributes and only has a constructor and a status method. Okay? Does that make sense? Think about what you'd have to do that. Okay, what would that code look like? So when we come back on Thursday, right, we're going to talk about this. We're going to pick up from here, and we're going to add maybe 1 or 2 more attributes, and we're going to move into the next thing that we need to add to this now. Okay? Questions? Welcome to the next section of the course. It's all OO. Still vanilla Python, though. Okay, we're not getting into anything else quite yet, but it's coming. All right? If you have questions, stick around. Other than that, we'll see you on Thursday.
So many possibilities.
Oh, man.
Yes, sir.
I don't know why it's giving me an invalid syntax right on my right on my rep thing, but I thought I copied it exactly how you said it.
You might have.
Just on a quote. I also keep on getting it on house 4 for whatever reason.
Do you
Plus
still have?
style, rep plus style. You got a concatenate rep with that string of styles. Just put plus style.
Okay.
Professor, for that question that I needed to,
Originally I had him as K. I switched.
I did
it to
everything
S.
you did
Mhm.
while you had the time to figure it out. The only difference I made was I had
You
rep
need to have
plus rep
STY
right
as
here.
an argument.
Rep
But it-
in
rep
it.
plus.
Right.
You see,
So I
so
did
you
rep
have-
equals
so you
rep
have
plus
everything
rep.
separate. So change
2
this
reps
to
are
STY.
only going to take whatever this is
Right.
and multiply it close.
Okay.
No,
So it
it's
didn't really
STY.
make a difference.
That's STY.
Shouldn't.
Okay.
Other than you
Add
add extra
STY
stuff.
as
Right.
put a comma.
Now-
No.
Back to the original question.
Go inside your argument.
Thank you.
Questions on that? Once you were able to make that determination, then you could go ahead and say, yea, verily, if this is true, then it is a right triangle. Does that make sense to everybody? It should have. It should make sense. Okay. Now, I saw a number of sort of classic problems. People did equal signs for this when it should have been this. All kinds of stuff like that. And I tried to circle those for people to sort of remind them, hey folks, listen. Right? But I think in a lot of cases, the problems I noticed were problems that people didn't take into account. You don't know what's A, what's B, or what's C. How to assign that. And to blanketly say one conditional will solve this is wrong. You need to be able to say, I don't know if it's A and C. I don't know if it's A and B, or vice versa. And then it's B and A, B and C, and so forth, right? So this is all from a sort of how one would solve this problem, like the only possible way to go. Right? And that's really it. And once, if you can say, yea, verily that's true, then you can go ahead and say, I have a right triangle. Okay? So, anyway, that's what I saw in general. So if you had a comment that said, hey, conditional or logic failures, right? I was actually surprised at how many people didn't understand this. I mean, I even gave the equation. Okay? I mean, this is like fundamental math. Does that make sense to everybody? My friends, we're going to be looking at stuff a little more difficult than this shortly. When we start talking about movement on the screen and so forth and so on. Okay? So you're going to have to do math. I don't care what you think or what you say. There's no such thing as not working with math. If you're in this field, that's a requirement. Okay? Any questions about that? If you have questions about the way your stuff was graded, please see me. Right? But I think I was a little generous on this one. Could have been much more vicious, like I normally am. Right? All right?
All right.
Anyway. My midterm's coming up across the street. Everybody's shaking already because they know it's coming. Anyhow, questions? Concepts? Anything? Like I said, if you have questions on how it was graded, please see me. All right? Other than that, we're going to continue on with our adventure in classes. Okay. So, let's see where we left off. Yes, sir.
What was the advantage of, like, so I was looking at the notes. What's the advantage of defining the input in the main? So the input is, you assign, so you have NBR equals the integer of input, how many bedrooms are in this house.
Okay.
Right? You can't have the input inside of the definition str. No.
Here's the problem. Okay, and we're going to really start focusing down on these ideas. But one of the legs of the OO stool, right? Literally, I mean like the OO, they call it a stool, right? But here is the chair, so to speak. And this is OO. Remember, and I want to repeat this. I will repeat this throughout the semester, remainder of the semester. Right? This paradigm, the object-oriented paradigm, you will learn it line, hook, line, and sinker, rote. I don't care how you think. Right? This is the only paradigm. If you get a job in the real world, or think about getting a job in the real world, it's all OO. Okay, so, and I don't care what language you plan on programming in, doesn't matter, the message is the same. Okay, the concepts and so forth, right? But, so one of the legs is called encapsulation. The other leg is called polymorphism. There's one. And what's the other one? This is all in the text, folks. This is all in the slides. Come on. What's the other one? And that's the one that you're missing. It's part of this. Reuse. Okay? Reuse. And reuse means you write the code once and you use it all over the place. Right? And it's a very simple concept, right? Time equals what? Money. And if you're constantly rewriting code, you're doing what?
Wasting money.
You're wasting money. So if you put that into the get the information, give me the length or whatever it is, right? If you put that into the method, that decreases the reusability capability. That's why. All right? And we're going to be changing that up. Right now, I'm putting it in the main. Soon, that stuff is going to be part of something called a get and a set. That's going to be part of the class definition. Okay. Right? So, like I said, the main is going to go like this, and everything else is going to go like this. Okay? But the idea here is that we want to write stuff that we can reuse over and over again. We don't have to reinvent the thing, right? You look at the problem, you go, oh yeah, I need a class for that, right? And when you think back on some of the stuff we've done in the class so far, in the course, I don't want to use the term class too much because I don't want to confuse me, but stuff that we've done in the course so far, using a class would have been a lot simpler if you guys knew what that meant, and be able to talk about it. Okay? Because remember, Project 3, all classes. So you're going to have to understand how it works, what it does, and why we're using it, right? And you're going to need to talk about it in terms of at the level of the code. Not, well, I'm using this because it's for my ammunition. No, that's not what we're doing here, folks. Right? We're learning about code. I'm using a class implementation because I can reuse it, right? And I can use the methods from that class to load my ammunition, remove the ammunition, all that kind of stuff, right? We'll have a class called, for example, ammunition. We won't have to worry about the little things anymore because it's all going to be there because you wrote it all. Okay? All right. Any more questions? Like I said, we're heading in on all of this stuff. We're talking about it. Okay? So let's go back to the future. All right. Let's see if my stuff is working today. So when we last left, right, let's see what my notes say. Let's see. So it wasn't on Tuesday, right?
When we were talking about house and stuff, that was on Tuesday after we.
Right. Oh, house and house type. That's
Yes.
good. House and house type.
We didn't get into
Okay.
the chapter, though.
We didn't get into chapter 8 yet.
No.
So let me see if I have my house type code with me here. I think I do actually. That one. Let's get here. Let's see. Let's see if we got it. Again, we're just philosophizing here. Here's my house type. I thought I said house type. Nope. You know, does anybody have a copy of it?
I do.
Bring it here. Put it on a stick. Oh, you got it on there?
Yeah.
Okay. That's here. I'll let you drive. Okay, cool. All right, let's go back and have a look. Just to once again sort of review what we have going on. Why is my display not working? There we go. Set the options here, 16. So when we last left, we were looking at this. Come on now. Come on. going, but it's not. Aha. Okay, we're back. So again, let's just kind of take it from the top. So what do we got going on here? How many instances of house type do we have? And what are they? We have 5 instances. What are they?
House 1, house 2, house 3, house 4, house 5.
Okay. Right? Very good. What are these guys called?
Attributes.
Okay. They're attributes, but the reality is they're called actual parameters. Okay. In Maine, when you send values like that, they're called actual parameters. Up here, what are they known as?
They're the attributes.
Up there?
Are there arguments?
No. They're what? They are members, but in this particular case, what I just said, right, I said inside those parentheses, right, in the definition, they're known as what? Formal parameters. Formal parameters. Okay, but they are the members, you are correct, right? What does the term self mean? What does the term self mean?
Isn't it basically like a way of localizing it specifically to the thing? So it just goes off itself instead of trying to be a global parameter or whatever?
What thing are you talking about?
Wherever you put self, so like self.bedroom makes it only inside the bedroom thing, right?
So let me put it a different way. Go ahead.
Is it referring to the current object? Like,
It refers to the current object. Right? Somebody's got a little oboe. Right? How you doing so far? Are we on track with what you understand?
yeah.
Okay. So self, in this particular case, is who? In this block here. House 1. Self here refers to house 1. Here it's house 2, house 3, house 4, and house 5, ultimately down here. Right? Self refers to that instance, that object. Okay? Does that make sense? The term self. So when we do this right here, and we're displaying the members, the values for those members, in this particular case here, right? Because remember, who does this, what method does that call?
Calls the find string method. Or, I'm sorry, just underscore str.
Yeah.
Underscore.
Right? It's the status method. Tell me what the value of my members are now. Okay? It's one way of looking at it. But self here, in this particular statement, refers to which members?
NBR and ST.
Correct, but which, for which instance? House 1. Down here, it refers to house 2. The values for the members of house 2. Right? And then the same thing for print 3 would be the values of the members for house 3. And so forth. Okay? Is everybody with me here? So, we've talked about this guy. What's this guy known as?
Constructor.
It's the constructor. It's the general contractor, right? It's the one that's responsible for building the structure in memory. Okay, underscore, underscore, INIT, underscore, underscore. Okay? Does it make sense? So, we're at that point now. Ready? Let's make that jump over to the chapter now. Chapter 8. So we can round out the conversation a little bit. Okay? So let's go over here. And let's look at chapter 8 slides. Yes, sir.
What were the attributes and the parameters of the constructor called again?
Well, any function definition, right, those are called formal parameters. Formal parameters, but they are also the members. They're the attributes, and that's how it's set up in Python. So, chapter 8. Let's go back to chapter 8. Now that we've had this little discussion, let's come back and take a look at it in a real simple form again. Okay? Because there's a few things we haven't talked about yet. As a matter of fact, let's close this guy down for a while. Let's open a new Python session. While this is booting up. All right, so let's take a look at our little conversation, and it's all about critters. Okay? So here we are, right? We talked about the OO, we talked about the attributes, right? Now, let me say that, and I've already sort of intermixed these two naming conventions, right? Attributes, the newer terminology is members, okay? They're one and the same, and we're going to probably mix them up a few times yet as we're going along, right? We know what a method is, we know what an instance is. To instantiate, to create an instance of the object, we have to call the constructor, right? You got to call the constructor, right? Right? This goes through all of these kinds of things that we've just talked about, right? So let's go out and let's step back just for a minute and talk about something a little different now, okay? So here's a really, really, really simple class definition, right? It's so simple, it doesn't have a what? What's it missing?
It's missing a constructor.
Constructor, right? So, if you have no constructor in your class definition, what happens is the system says, hey, you don't have a constructor, so I'm going to give you what's called the default constructor to use to create your instance of the class. And it's okay, but like anything else like this, right? And we've seen this sort of move before, when you create the object, right? What you're going to get is nothing more than a blank space of memory, right? And that's literally what's happening right here, right? So what's the instance there? Or what's the object? Oh, no.
Crit is the object.
Crit is the object. It's the instance of the critter class, right? This is the class. And just like before where we said house 1 is equal to house type something blah, 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 same thing here. Crit equals critter. Okay? This is the class. This is the instance, the object. So the current instance is what? Crit. And by the way this is set up, okay, we can directly call the method, right? The methods that we've been using up to now have underscore, underscore something, correct? Are you with me here? Constructor, the status method, the underscore, underscore str. We don't have any of that, right? All we have is this talk guy. So we can use what's called the access identifier, right, the period, to say, here's my instance dot talk. Instance dot talk says I'm going to call this instance and this method, okay? Because remember, what we're actually looking at here, right? So we have this object. It has no attributes or members. All it has is what? One method called talk. That's it. Right? So this is crit, and crit has one method. Boom. Every object you make of that class definition will have, in this case, one method called talk. Its own copy of it, actually. Right? Does that make sense to everybody? So if I make 5 copies or 5 crits, crit 1, crit 2, crit 3, crit 4, crit 5, or however many million I'd like to make, every single one of them will have the one method called talk. All right? So let's execute this code. Let's fool around a little bit. All right? So I'm grabbing this code. You're going to have to make some adds to it, remember, because it's 2.5.2.6 syntax, right? So you have to put parentheses around this. Right? I don't like this, right? Because you cannot get away from the using main, right? The minute you start walking away from that, you're asking for trouble. I mean, the purpose of main is to become your client, okay? Do that. Okay, so I'm going to run the code. Desktop. And we should see, hi, I'm an instance of the class critter. Does everybody get that when you run the code? All right, we're doing the simple stuff. There's one more thing up here. I'm just going to mention it. We will come back to this idea because that's really part of the beauty, if you will, of OO, right? And that's this thing right here. It's called object, and it's in between the parentheses. Okay, we haven't gotten to this yet, but we will. It's coming. Object represents as an identifier for a base class. Okay, we'll talk more about that, but the term object, in case anybody's wondering, because in our house type definition, we didn't have this, did we? It just had the 2 parents and that was it. Okay. Now you have this thing called object. And that's, like I said, used as an identifier for a base class. Okay. We'll leave it at that for the minute. All right, so this talks about all of the stuff that we've been dealing with already, methods, how to call them, instantiating the object, invoking a method, right? No constructor, you get this, it's blank memory. And if for the moment, that's fine. We have no attributes, right? Does that make sense? We've seen this before. Where else have we seen this? I'll let you think about that one when we continue on. Okay? Constructor, right? No problem. We're all good, right? So let's put a constructor in now. Put a constructor in. Right, so I'm going to put him sort of in the proper order. Right. Yes, sir.
Aside from the constructor being on top, are there other methods that have to be in order? under
No.
the constructor?
Here's sort of my philosophy on this, right? I like to have a standardized layout for my class definitions, right? Because your definitions are going to go like this. Because we got a whole bunch of methods that we're going to be putting in for the classes as we go along. I don't want to have to look through a whole page worth of methods if I want to find the constructor. Constructor to me usually is right at the top because it's what's creating the object. Right? But it's not a written rule, right? It's sort of a de facto standard. Right? Anything with an underscore is generally at the top of the class definition. Okay. So let's run the code again. We have our own little constructor. Right? It's not going to do much other than print another line when we go ahead and create that instance called crit. We could do this. We could create multiple objects, right? We've done this, house 1, house 2, right? Crit 1, crit 2. Concept is the same. It's just the names have been changed to protect the innocent here. Okay. Not even a smile, really. Jeez. You guys all missed the sort of, the names have been changed to protect the innocent here? All right. Let's get some attributes, some members out there. We're going to start out with the first one. We're going to add ourselves name. It should look pretty familiar. So I'm going to modify this guy here to add name to the picture. I don't really need this line anymore. So if I would like to see the name in my output, I don't have an str method, for example, right? But I could create one pretty quickly. I can just go right back out to my old code on the desktop here. Grab my str method and doctor it a little bit so that it's relevant to what I'm doing. This time, critter instance, and here are the member values. And in this particular case, all we're going to say is name and self.name. And oh, by the way, I don't need to change this to a string anymore because it's what? It's already a string, right? So we'll get rid of these guys for a moment. This fella here. And we'll run the code. Oh, it takes 2 arguments, 1 argument given. So now I need to add something. I'm going to add Randolph. It's a nice name. I like that name. And I'm going to print crit. So this line onto itself here, print crit, right, is going to call who? And don't say Ghostbusters.
The object?
We're going to call this guy here. When we say print crit, we're going to call the status method, and we're going to send it the instance or our only object so far, crit. So let's see if it works. Maybe we're out of luck here. It works wonderfully. Okay. So here's what I want you to do. I want you to create 2 more instances right now. 2 more instances of critter. I don't care what you call them. Give them different names. Update the status method that's up there and run the code. Actually, I'd like you to add a couple more things to that. Add not only a couple of instances, I'd like you to add a couple more members. Like, so maybe a color and maybe number of legs. Okay? I'll be back.
I'll be back.
How we doing? Anything on already?
Here's gonna be some copies in that form. No, leave that there. Thanks.
Okay. Thought you were gonna submit your code already or something.
Have a think about it on the way over. Thank you.
No problem.
What is my working order?
So I want you to create 2 more instances and add a couple of attributes. Like one could be like color, maybe number of legs. It's critter, we don't know. Whether it's a spider or a squirrel or we don't know. Does that make sense? Who's got it done? Got it done? Lead the way. Any one of those slots. There we go. Okay. Thanks. You do me a favor, copy that to the desktop, and then take your stickers. Thank you. All right. How's this measure up to what you were doing?
For some reason, it's only turning against this one. Even though, or like it'll print, so I can do it again.
That would help.
Yeah.
And then you gotta update something else too. You gotta update your status method. Underscore str. Okay. And it doesn't have to be string anymore because name is a string. Right. I'll give you another minute or two, and then we're going to make some more changes to this. Everybody all right? Is it working now?
I don't get what you mean by update this status.
The output, right? When you say print instance, right? This guy here, you've got three things here now. You only have one on the output.
So I need. Okay. Okay, I got you.
Doing all right? Okay. You doing all right? Doesn't look like it. Got some stuff happening there. Doing okay? See some errors going on there. Look at your code compared to that code. Going? Yeah.
Hey. I did it.
I'm telling you, I think half the problems that people have are keyboarding issues. I think you should all be going to Typing 101 or something to improve your typing skills. Anyway, so let's go back to the material here for a second. Right? So we've gone ahead, we've done this, initializing the attributes, right? We can go ahead and send the values, right? The talk accessing the attributes, right? Here's the thing that's kind of interesting. Right? You can do things this way. Right? I want to print the value of my critter, a value of one of the attributes of my critter, like this guy here. Right? I can say, it's not crit one here, it's just crit. I can literally say print crit.name. And this is going to bring up a whole new avenue for discussion here in a second. Right? So I can run this and I can get to the individual member of a particular instance. Does that make sense? Questions about that? So I'm actually able to get the name. And like we always say, if I can print the name, I can do what with it? I can catch it and look at it, examine it. All the stuff that we've been doing all along up to now, I'm now going to be able to do against these values. So let's update our little chart here. Right? So now, right, our crit has a constructor, underscore init, has an str method. It still has the talk, and we have what? 3 members, right? We have name, color, and size. Does that make sense? So every instance of the class, now every object will have this, right? So crit n. Every single critter object that we create will have those elements in it. Questions on that? So 3 members, 3 methods: talk, constructor, and str. Any questions? And we can get a particular member, right? I'm able to get a particular member right here by simply giving the instance name and the member value, whatever it is, okay? And I could do that for any of them, color or number of legs. Right? Questions on that? So here's where it gets interesting. We have this, we're doing this guy, right? Class attributes. Let's add something now. This is different than what we've talked about so far. This is called a class attribute. It's not a member, not a attribute of the class instance. It's a class attribute, okay? What exactly does that mean? That means this guy here, for example, and doesn't matter what I'm calling it, it's a class attribute. I could call it Frank, it doesn't matter. The word total has nothing to do with anything other than it's relevant to what we're about to do, okay? And this is the part where I think you guys might find some interest, right? I'm going to, right underneath this guy, add my total. It's supposed to be total. Equals 0, okay? And what this class attribute is going to do is it's going to keep track of how many instances of the class I have currently existing. So in my constructor now, I'm going to add another line of code that says critter dot total equals critter dot total plus 1. And you might say, what does that mean? What are we doing here, right? Like I said, this is going to give us the option or the ability to keep track of how many critter instances we have out there, right? So I can do it both ways now. It is a class attribute, which means all instances of the class, number one, has this information in it. Okay? And I can interrogate the class itself for that value. How many things I have. Let's see what that means. Right, so here I am. I'm going to go out and do this. And I'm going to sort of document what's happening. So here, print. This is now the class at the class level. Right? And then I'm going to say, the other way of finding out what it is, I can look at it at the instance level. In other words, I can check any instance of the class now, and I will get that information. In other words, how many critter instances do I have? Ready? Let's check it out. What value should I see?
3.
In both cases, I should see the value 3, except I have a problem. What am I not doing? Print needs to have parentheses. Sorry. Lousy grammar rules. Who came up with that type? Let's run it again. I have a problem at the instance level. Why is that? Why do I have an error there? What's that? Because is there a crit 1 out there?
No.
Nope. So now we should be good. Let's see. Look at that. So I can interrogate at the class level if I want. So I could literally set up a method that would look at that value and say, if I have more than 100 critters out there, stop creating them. Or if you only have 5 critters out there, create 5 more. Right? Do you understand what I'm saying? And various instances of the class can talk to each other. It can keep track of themselves. So if I say I need a wave of enemy objects to be created, 50 of them, right? It's pretty simple to figure out how many I have, right? All I got to do is look at that value right there, and it will tell me that.
Would you put that condition right underneath where you define that variable? Or you
Nope.
put total?
As you notice, I haven't done anything yet with that problem, right? So far, I've just displayed the values. You can start testing that concept out, right? All you have to do is, if I can print it, that means I can grab it. And I could just say if critter.total equals 3. I'm just going to print a comment, right? Print. Might need to create a few more. Does that make sense? I'm taking a look at that. Okay. So let's see what happens if that works. Should we see something? The answer is, if you do the right syntax, you'll be maybe golden. Might need to create a few more. More importantly, remember what I said, you don't want to put any of that kind of logic into main anymore. You want to minimize that stuff. So we probably should create another method here. I'm going to call it DEF. Add enough. Have enough. Right? And all that's going to do is this guy here, right here, because I can interrogate internally to the class. Because total is a class member. It's like, where have we seen this before? It's not inside of a function. It's at the top of the code. What do we call those? What did we call those? Huh? Globals. Thank you. So I could do this, and then I can say return. Actually. See if it works.
If should I what?
See if it works.
Have enough left to buy.
What are we going to do?
If should I critter period don't have enough.
Needs to be crit dot. You got to give an instance, right? Everything else requires an instance. Crit have enough. Takes no arguments, one given. Ah, what's the problem? What is the problem here, my friends?
Crit isn't an object. You don't have self.
Gotta have self. And again, I'm just fooling around with functions and stuff. I'm just experimenting around. But I've created a new method, right? And that new method, I'm going to call have enough. Have enough says, I have a little switch called need more equals false if critter.total is equal to 3. Crit might need to create a few more. Need more is equal to true. Return need more, which is now going to be set to what?
True.
Well, need more is set to true, but on the return trip, what is that return value going to be assigned to? Should I? Right? This says, right here, I'm calling the function, the method, have enough, instance crit. Okay. Remember, the value of total is known to all instances and the class, overall class, for how many instances of crit we've built. Right? So I'm going to return the value if it says true. If should I, right? Going to do it. What data type is should I? What data type is should I? A what? Well, what is the data type of this right here? It's a Boolean, it's true or false. And I'm just saying, if should I? In other words, is it, if it's true, do something. I don't need to say if should I is equal to true. I'm cheating. I'm doing what you guys would do. I don't want to type so much.
Where does it determine if it's true or false? Like,
What do you
that
mean?
something happens. So if critter.total equals 3,
Right.
need more equals true. Where is, so you initialize need more to false.
Yeah.
Okay, what?
If critter.total is equal to 3, I print a little comment, and then I change the value of need more, which was false, to true, and then I return.
Oh, okay,
more.
and then you said you cheated down there, so.
I cheated
if
down
it's
here,
true.
and I didn't say if should I equals true. I took a little,
Yeah, I get it. Okay.
and you can only really do that on a bool.
Yeah. I got this all.
Does it work? You
Yeah.
got your code working? But what am I able to do now? I'm building some control mechanisms. Right? And I want you to think about this because you wrote some code recently that talked, some people wrote some code recently that talked about level. Right? And you could say, depending on the level, in this case, if I have only 3, let's get 5 enemies out there. Right? The system manages itself. Does this make sense? Very interesting. Right? And you can manage the entire program by doing this sort of thing. Right? But you'll also notice, and right now I have this guy in here like this. Normally what this would be is it would be calling a function. There wouldn't be a print statement there. You'd be calling a display function or display method. Remember, we still have functions outside of classes. Right? We have still generalized functions out there that we can use. And so these are called what? Methods. We can still have functions outside of classes. And you will. You're going to have lots of them, just like you did before. Anyway, continuing on. Okay? We are just having so much fun, I can't stand it. Right? Accessing a class attribute, we just did all this. Right? Yes?
What is the benefit of still using a function outside of a class?
Lots. As much as it used to be before. Right? Think about what's happening. Okay? You were controlling your program using function calls, right? And then we brought along some data structures. We did tuples, lists, dictionaries. They didn't contain functionality. Now, we got these guys. These are completely self-contained. They have members and methods to manage the object. We've just stepped up the rung on the ladder with regard to data structures, my friends. Majorly stepped up. Okay? So now you've got this self-contained package. Think about 5 or 6 or 100 classes, potential classes you can take advantage of. You could have a hero class, an enemy class, an overall game class, right? Which we're going to have, and stuff like this, right? And those will be self-contained. They'll be self-contained. Create the instance, you're done. Next. What do you want to do next? As I said, these are really, really, really simple classes. I mean, we're not doing anything here. 0. I mean, literally, we're creating the object and show me what their contents is. We're not doing any logic. Right? So let me throw this out at you. Okay? You're going to be crafting classes where each of the classes has their own behaviors. In other words, their way of moving on the screen, their protective mechanisms, right? How the collision works. Those are all nothing more than methods inside of the class definitions. So when you create the object, it's all done. One statement. House 1 equals house type. You get it all in one shot. You can create 50,000, right? Every one of the instances of that class will have that information. The attributes and the methods to execute those members. Okay? Doesn't that sound interesting? You're going to love it. You are going to love it. You thought debugging was fun before? We're just starting out, boys and girls. So you all want to be game developers, eh? I'm just kidding. All right. We're going to come back to this concept of a static method, primarily around the fact that it's a little early to introduce this. But we'll come back to this. Multiple instances. All right. So let's get into the philosophy here of the whole OO approach, right? And I brought this concept up earlier. And what does this mean? And we've been practicing this, believe it or not, all semester long already, right? And this is the idea of a separation of the definition and the implementation. Okay. What's going to end up happening is you're going to have one code file that's going to contain your main, your client, and then you're going to import all of these other code files that are each or depending on how your code looks, will have either a file for each class definition or a library of classes based upon what you're trying to do. Okay? So we're going to be practicing this encapsulation concept. We're going to be separating the definition and the implementation from the main. All you're going to know in main is, how do I get this information? How does it work? All right? So I'm going to step back for a moment. I'm going to turn the clock back. And I'm going to take you back to some of the data structures we've seen recently. Think back to the list data structure. What did I tell you when I said the functionality for a list? What did I call those? They were methods. I said list name dot method. Remember this? And you saw that little table that said for an insert you needed to supply the location and the value you wanted to insert into the list.
Yes.
You had no idea what was going on underneath the covers on how that was being implemented. But all you know, or all you knew at the time, was list dot insert and then the arguments to go in there. Guess what a list is? It's a class. The minute you hear method, you should automatically think class. Right? Does that make sense? And that also was the case with the dictionary. Remember that? Remember those guys? The key value pair? It had its own set of methods. Right? Dot something, access specifier. That dot represents a method. Instance dot method name. Okay? Does it make sense? It should start clicking here pretty soon. Because we're doing it right here. Right? If you look into this code, you'll notice that that's what we're doing. Right? Here's an example, crit.name, but that's really not. This is actually a much more of an example of what I just mentioned. Give me the instance, dot had enough. Had enough is a method of the critter class. These are our own handcrafted classes. In that case, the list, right, that's a system-designed class, right? Does it make sense a little bit? That's the direction we're going. So let me give you a little advanced commentary. Ready? Take a guess what Pygames is. a giant class with hundreds and hundreds of methods in it. The first thing you're going to do when you start using Pygames, ready? Here's the opening statement when we get there. Look familiar? You're going to create an instance, a local instance of Pygame in your environment. Then, guess what you can do? Once you create the object, what can you do?
Use all the methods.
You can use all the methods, use all the methods that are available as part of the library, part of the class. Right? Starting to click a little bit?
A lot.
Good. Like I always say, I can smell the straw burning from here, right? Anybody know what that refers to? Seriously? You guys are all deprived people. Like really deprived people. You ever heard of the Wizard of Oz?
Oh,
attention to the man
because his
behind the
brain
curtain.
power, yeah.
Right? The straw man. Anyway. Oh my God. You guys got to get your heads out of games, man.
The straw man,
It's-
you mean the scarecrow?
Yes, it's destroying your mind.
Oh,
I feel like a really old guy. Anyway, so if you go out to, for example, pygame.org, guess what you're dealing with in Pygame? Right? All the right? All of the methods from the Pygame class, the Pygame library. Right? Import and initialize. Import Pygame and pygame.init. Pygame is so old they didn't even have underscore yet. That's how long this has been around.
Dang.
Okay? We'll come back to all of this stuff, but I just wanted to sort of give you the reasoning for the madness here. Okay? Yeah, there's all kinds of great stuff. That's your next best friend, right after the python.org live. Okay? So let's go back to this guy, right? So encapsulation, the client code, guess who the client is? Who has been our client all along?
Player.
Main.
Oh.
Main is what's calling, creating, it's taking advantage of all the stuff that's out there, right? And the objects, right, once you create your objects, right, you can call the methods that support them. Okay? Let's go to this next topic. This is kind of a tough one to talk about, right? Up until now, right, everything we've dealt with regard to our members are what's called public attributes or public members. Okay? A public member is a member that you can go directly at and get the value from, right? So an example in our current code would be this guy right here. Crit.name. Name is an attribute or a member, right, of the class. I can go directly at that guy and get the value. Okay? That's called a public attribute. Okay, public member. On the other hand, there are times when you don't want to have that. You want to protect that attribute or member, right? And that's called defining it as private. Yes, sir?
Would it be like in a game where you have certain actions that are locked unless you enter in a specific code? Like a cheat code, if you will?
I doubt if they're using this technique for that. It's just a conditional, more than likely there, right? But an example of something like this, and it's, again, it might be a little bit dated because I think this information is just out there for everybody, would be like Social Security number, right? You don't want everybody to go and get your Social Security number, would you? You'd want some special something, some sort of security on that information. So you would want that to be designated as private. So, if that's the case, that's what they're talking about here, you'll notice this right here, underscore underscore in front of the attribute or member name. That's an indicator for a private attribute. And you might say, well, okay, I said it private, but it's mine. I want to be able to get at that member. So the rule is the following. You need a public method to go against a private member. And actually, the better way to do it, right, is to actually have a private method as well. And a private method we've already seen. That would be your constructor, or that underscore underscore str. Anything with underscore underscore in front of it is private. So the preferred way to do this, right, would, if you have a private member, have a private method specifically to get that value, put it into the private method, and then a public method that will call the private method, right? Does that make sense? That way, you can put a password or some sort of security string into the private member or private method. Right? Does that make sense? Mm-hmm. Question?
Yeah. So for so if each of the private things are defined by the underscore, does it matter if it's in front of, behind, or both?
Got to be in front.
Okay.
Has to be in front. Okay. So private member, private method, public method to call the private method. Okay. That would then allow you to put some sort of, for example, password on that if you needed to. Okay. And you can see what they're doing here is they're actually using, they're going after the private method here, using a public, this talk method. It's okay, but you really can't protect against that. Right? You really would prefer to have a private method that you can add another attribute to that can be tested prior to getting that information and returning that information on a return statement. Yes, you have a method that calls a method. That could call another method. That could call another method if you wanted to, right? You're the one designing the code. Okay. Questions, comments? It's getting exciting, right? Lot to think about now. Lot to think about. Public method, and as you can see, here's the public method. This is a public method. It's calling the private method. Self dot underscore underscore private method. So what is that private method now being considered as? A member of the class. Now we're mixing up members and methods. Technically, methods and members are all considered as members. Okay, if you look at the technical definition. For our small minds, members and methods separated, it's just perfect. Okay, for a while, we're going to continue doing public members. Okay, but we're going to get to a point where we're going to have to hide some information from the different characters in the games. Right? Just to give you some experience with this. So, let's talk about your homework. Let's talk about that homework. So here's what I want you to do. I would like you to take 2 of the new members that you just built. Right? Okay, use that example. What I want you to do is add 2 more members to this that we're working on right now, our little critter class. And I want you to make one of those 2 a private member. Okay? So you're going to have to create a private method that can be called from a public method. And I want you to display the value. So you're going to need a special underscore underscore str method to do that. Does that make sense? So 2 more members. One needs to be private. Okay? And then I want you to create a public and private method to get that information from that private one. Okay? Shouldn't take a lot, but you're going to have to think through the problem. Okay? Does that make sense? We have to get really solid on these ideas, folks.
So you just need it to be callable from the public one?
The private member?
Yes.
Yes, but yes. I'll leave it at that. Right? I'd like to see it being called from the main, but it's okay. Call it from another public method. Okay. Just so you can get the value, I want you to display that value, the private value. Does it make sense? Questions? So, with that, this is all that stuff. All right, so when we come back, we're going to start out with gets and sets because we need to get that straightened out. All right? Gets and sets. All right, if you have questions, stick around. If not, I will see you on Tuesday. Yes?
So let me just get this straight. We need to make 2 more methods, 1
No,
public.
2 more members.
2 more members, okay.
One has to be private. I want a private method to call the private member, and then a public method to call that private method. Okay? It's getting complex now, eh?
Yes.
Oh, man. Guys, your eyes are going to roll back in your head.
Pretty soon.
Just warming up.
Tuesday, Professor.
See you then.
Good luck with today's lesson.